Okay, 8th graders, we're talking about comparing linear and nonlinear functions. And our essential question is, can you recognize when a pattern in life is linear or nonlinear? And a linear function is just a line. So a nonlinear function is does not have a constant rate of change. And when it's graphed, it is not a line. So, does the table represent a linear or nonlinear function? And we need to explain why or how we know this information. So, we could graph each of those x and y values, but this is going to require some pretty large graphs. And there is a way to tell. So if you're ever stuck on one of these problems, you can just graph each point as an x value and a y value and see if they form a line. But you can also see, okay, what's the change from this x value to this x value? And it's plus 3, and plus 3. And then we can figure out the change from the y values, and it's minus 8, and minus 8. And as x increases by 3, y decreases by 8. So the rate of change is constant. Every single time the same thing is happening. X is increasing by 3, y is decreasing by 8. And because every single time the same thing is happening, then this is going to be a linear function. If we take a look at the second one, we have an increase of 2 on the x's. Each time it's an increase of 2. And then on the y's, we have an increase of 9, and then an increase of 22, and then an increase of 55. So because this is not a constant, each time the same thing is not happening, so this would be non-linear. On this next section with the graphs, it says, does the graph represent a linear or non-linear function? And I forgot to draw them on, but here are the lines. They should look like this. And like this. And when they're in a graph form, it's really easy to see whether they're linear or non-linear. This is a curved line, so it's non-linear. And this is a straight line, so it's linear. So nothing too crazy there. Let's turn your paper over. Okay, on this next example, we're looking at a real-life example of a graph in the data table. So we have to decide whether the graph is linear or non-linear, and then we're going to compare the two following objects to tell which one has an increasing speed. So the parachute jumper. After 0 seconds, he's at, or she is at 300 0, 300, and these are going up by 30s, so this would be 270, 300. 1, 285, 2, 270, 3, 255, 4, 240. So this graph is going to look like that. And the bowling ball is at 0, 300, 1, 284, 2, 236, 3, 156, and 4, 44. Okay, so decide whether the graph is linear or nonlinear. So the parachute jumper is linear, and my falling bowling ball is nonlinear. And then we have to compare the two falling objects. Which one has an increasing speed? Well, this one is going down 15, down 15, down 15, down 15 every time. You can see on the table it's decreasing by 15 every time. This one is decreasing by 16, and then let's see, 284 minus 236 is a decrease of 48, and then a decrease of 80, and then a decrease of 112. So the bowling ball is going faster and faster and faster as it gets more toward the ground. Okay, sorry, knocked over the camera. You can all make fun of me for it tomorrow. Last, we have to graph the data in the table and decide whether the function is linear or nonlinear. So you should be able to do those two problems. If you needed to use a separate sheet of graph paper, especially for number 1, you may. And then on the last two, numbers 3 and 4, you have to tell whether the graph is linear or nonlinear. Have a great night.